All right, let's talk about log properties. Let's review a couple of the log properties because we're going to be using them when we condense and expand logs today. And first one is if you have log base b of b, that equals 1. So when your base and the argument, what's in the parentheses, are the same, you get 1. When you have log base b of 1, that equals 0. And it doesn't matter what your base is. If your argument is 1, it equals 0. When you have log base b of b, that's going to equal x. If you have b to the log base b, that again is going to equal x. And then if you have two logs set equal to each other and they have the same base, then their arguments must be equal, as long as their answer is in the domain. Now let's look at our new rules for our logs. We have what's called the product rule. Remember, product is just multiplication. So if we have log base b of mn, so two things multiply together, multiplication makes us bigger, and so does addition. So this becomes log base b of m plus log base b of n. They were multiplied in one log. We break them up, everybody gets a log, and we get to add. Quotient, remember, is division. So if we have log base b of m divided by n, remember division makes us smaller, and so does subtraction. The numerator is going to be positive. It's your denominator that winds up being negative. So when you have log base b of m divided by n, that turns into log of m divided by log of n. And finally, we have what's called our power rule. If you have log base b of x to the m, that m gets to come out front. It becomes m log base b of x. We have two things that we are going to do with these product and quotient rules, and of course the power rule. Our first one is to expand. To expand logarithms, we're going to use log properties to break apart a single logarithm into several logs with simplified arguments. So no exponents, multiplication, or division in the parentheses or in the arguments. The other way is to condense logarithms. To condense logarithms, you're going to use log properties to bring together, or you can look at this as combine, several logarithms into one single logarithm. Okay, so expand is break apart, condense brings them together. Let's look at some examples. Our first one, we have log of 1000 x. Remember that when you have something like 3x, that came from 3 times x. Multiplication makes us bigger. So this becomes log of 1000 plus log of x, because addition makes us bigger. Multiplication and addition both make us bigger. They go together. Whenever you think you're done, you need to go back through, make sure that you don't have any exponents in your arguments. Make sure we don't have any multiplication in the arguments. And then you need to make sure that the base and the argument are not the same or don't have anything in common. Remember that when you see log with no base, that's our common log, which is log base 10. We just don't write that. Well, 10 and 1,000 have something in common. We know that 1,000 is equal to 10 cubed. So we are going to plug this in to our log. Instead of log base 10 of 1,000, we're going to have log base 10 of 10 cubed plus log base 10 of x. And here we have an exponent which needs to come down. So now we're at 3 log base 10 of 10 plus log base 10 of x. And then we look again to see if we have any exponents in our argument, and we don't. Make sure we don't have any multiplication, make sure we don't have any division, but then we need to see if our base and our argument are the same. And in our first one, our base and our argument are the same. Remember, when your base and what's in the parentheses is the same, it becomes a 1. So log base 10 of 10 is 1. We're now at 3 times 1 plus log base 10 of x, which gets us 3 plus log of x. I'm not going to write the base 10 because we don't write the base 10 for our common log. I only wrote the 10 because we were doing the work. Okay. Our next one, we have division. Division makes us smaller. Subtraction makes us smaller. So we're going to break this up. Natural log of e to the 5th. If you're up top, you're positive. If you're in the denominator, the bottom of the fraction, you wind up being negative. So we are going to take minus the natural log of 11. We know we're not done yet because we have that exponent, and that exponent needs to come out front. So that gets us 5 times the natural log of e minus the natural log of 11. If we look back through it, we don't have any multiplication in our arguments, no more exponents, no more division. So we need to see if our base and our arguments are the same anywhere. Remember that natural log is log base e, but we don't write log. There is no log in math. Log base e, we rewrite as natural log. But that means that we have to keep an eye out whenever we have the natural log of e. That means that our base and our argument are the same. So we're going to have 5 times 1 minus the natural log of 11. And that 1 again came from the natural log of e. 5 times 1 gets us 5. So we have 5 minus the natural log of 11. Last one like this. All right. When we're going with this one, if you watch a bunch of videos, they are going to take you step by step on how to do this problem. In all the years that I've been teaching it, when I go step by step by step, I lose students. So I want you to remember, if it's in the numerator, it's going to be positive. If it's in the denominator, it's going to be negative. Okay? All right. So we're going to break up everything that we have going on in the parentheses because we have division, which makes us smaller, and then we have multiplication going on as well. All right, so we have log base b. Let's do the numerator. It's x, y to the 7th. So that means I'm going to have log base b of x plus log base b of y to the 7th. I'm now to the 7w to the 4th. They're both in the denominator. That 7 and the w don't go together. They were multiplied, so we're going to break them apart. But since they're in the denominator, they're going to be negative. We're going to have minus log base b of 7 minus log base b of w to the 4th. So notice, if it's in the denominator, it's going to be negative. If it's in the numerator, it's going to be positive. All right. Going back through, let's take care of those exponents. We're going to have, sorry, I guess my hands are just really big or really fat and messing with my computer. We're going to have log base b of x. That 7 needs to come down. So plus 7 log base b of y minus log base b of 7. And then we have another exponent. So let's bring that exponent down. So minus 4 log base b of w. If we could combine any of our logs, we would, but all of them have different arguments. We don't have any more exponents. We don't have anything multiplied. So let's check our base with our argument. In the first one, b and x are not the same. B and y are not the same. B and 7 are not, and neither are b and w. So we have our answer. It looks a little gross, but it's okay. At least we don't have any fractions anymore.